Okay, yes. So we are on week 18, and we only have a few weeks left of new content, right? Because we moved of the Docker stuff, which was inside of Module 5. So that's now inside of where we are, Module 4. Next week will be the assessment. You're more than prepared. I'm confident that all of you will be able to pass it. Uh, and then we'll cover Kubernetes for about 3 weeks. And again, if you're feeling like you need that extra week, we can make that push because after assessment 4, you'll have weeks 24, 25, 26, 27, and 28, 5 weeks basically for the capstone. And that's a lot of time, probably more than you'll need. So we do have some flexibility. We can squeeze in a week here if needed, but we'll play it by ear. Okay, that said, let's zoom back to today's content. How has Docker Compose been going? How was last week's content?
She's pretty good, I think.
Okay, well,
Okay, let's see. Last Saturday, you covered, right, more CI/CD stuff. So that's very much relevant to the assessment. Today, we're going to talk about multi-stage builds. Not absolutely critical to the assessment, but definitely will get you some bonus points if you integrate it into the assessment. And we want to teach it just because it's important to know about.
integrate which part into the assessment? I'm sorry. What'd you say? Integrate.
Right. Like just like the last assessment, like there were kind of like some stretch goals and like optional or additional things that you could do.
Okay.
Yeah, like it'll just be like bonus points if you go that route. Yeah, if it should be clear in the README some of the stretch goals. I'll be sure to make it very clear. But as we talk about what multi-stage builds are, you'll see and understand why it's not absolutely crucial to the assessment. Um, it might not even be crucial to your use case, right? But it could be. It really depends on what kind of issues you run into because multi-stage builds are a way of optimizing your configuration and your code, right? And if you have, let's say, yeah, if you don't have a need for that optimization, like you're not running into issues where your container is not spinning up, it's resetting because there's not enough memory on the EC2, then you might not need to do this. Um, but we're going to cover it. It's good to know, and you'll more than likely use this in a real world setting. We use it in our primary application. I think the bulk of the applications I've worked on at Innova incorporate this, but I'm getting ahead of myself. Let's back up. Let's talk about what multi-stage builds are in the first place. Does anyone have any idea what they are?
No.
No.
I
Anyone
mean, I
want
just read what they were, but
to?
I don't know what they are.
Okay. Um, there really are. It actually is really simple. If you think about how you've already been writing out your Docker files, if you think about that entire Docker file as a stage, then a multi-stage build is just kind of a more complex Docker file, except it's not even that complex. Let's look at this example here where we have multiple stages. And you can tell what a stage is from this from statement. So we already know that we need this from statement when we're creating a Docker file because this is where we pull our base image from, right? So that defines a stage. You basically have the ability to use multiple from statements inside of your Docker file. And so if you follow your first stage where you end with a run or maybe even, well, I don't think you would end with a command ever. You can add an additional from that will start the next stage of the build. And this allows you to ultimately create a cleaner final image, right? Because the image that gets built at the end is the image that's going to be used in production. And there may be a lot of things in development that you don't need in production. So think about debugging tools, testing packages, anything that will help with the first part of the pipeline where you run checks to make sure that something's not going to fail in production in the first place. And you can really lighten up the size of your final image by taking out all those unnecessary things. Does that pretty much make sense?
I'm
To
gonna
me,
say
it'll
no.
probably make more sense once you actually do it, I think. Sorry, I didn't mean to cut you off.
Yeah, I'm just trying to understand why we would need to separate, I guess, stages.
Sure. Yeah. Let's let's look at the DevOps lifecycle. And this is something that I think we probably could be talking about a lot more often in the DevOps curriculum. I don't know if we talk about it enough, but just to go back to the fundamentals of the DevOps lifecycle, DevOps is really a philosophy, right? It's not a super concrete thing. When I think about software development and the full stack program in particular, I like to think of it as math class, being similar to math class. You're learning algorithms, you're learning how to solve uh, algorithmic problems and challenges. It's very logical, whereas DevOps is, yes, still logical, but also highly conceptual, kind of like a science class, right? So in DevOps, in full stack, you work with a lot of algorithms, algorithm challenges, you build applications in DevOps, you build infrastructures that support these applications. You work mostly in labs for your challenges, repeating a series of steps to achieve results, right? And experimenting along the way. That's kind of like how I like to think of the two things. So DevOps being a little more conceptual, there are steps, but these steps aren't always practiced, right? So poor implementation of a pipeline might be something that lacks testing, that lacks monitoring and observability. If we were to use what was it? The Equifax security breach as an example from like 2017, they didn't implement DevOps. They didn't have a pipeline, they didn't have life cycles. So when they try to apply the patch that fixes the vulnerability, they applied it at the wrong folder level. So it didn't actually install or apply at all. And basically, they thought they fixed the problem and they found out months later that they didn't actually fix the problem. If they had tests, they would have caught this. If they had monitoring, they would have caught this. So that's the whole idea behind DevOps, right? We apply practices that help the company, the organization as a whole. If you haven't read like the Google SRE handbook, it kind of talks about the concept of DevOps as, well, more so site reliability engineering being born from this divide between software engineers and system administrators, right? Software engineers want to release new features and functionality. System administrators want to do the exact opposite. They want to slow down releases to ensure stability. So like these two things clash. They're in complete opposition to one another. So that's how the idea of site reliability engineering was born. Let's take software developers and let's have them apply these system administrative concepts and practices, right? So why would you want to run a multi-stage build in Docker? It's for this exact reason, like this cycle. There are different parts of the DevOps life cycle. There's a planning phase, coding phase, building phase, testing phase, releasing phase, deploying phase, operational phase, etc. It's again, it's not like concrete that every organization will follow this exact pattern, but this is the general gist of it. So things like testing and linting, quality assurance, you don't need to run those things in a production environment. You run those things before you deploy the application, right? It doesn't make any sense for your production servers to be expending additional memory and resources running tests all the time, right? You test before you deploy. That's just how the life cycle is. You once you've released, once you've deployed, you no longer need a lot of these development phase packages and libraries and modules and all of that stuff, right? So let's go back to our multi-stage build. Do we have a good example in here? This doesn't even look like. Let me see. This again looks like it's not up to date. But I know that that was kind of like a very, very long tangent. So Flo, does that at least start to give more insight?
Yes. I
Okay.
guess seeing it in practice, like, so my understanding is essentially we're kind of relying on the cache. Is that correct? To kind
Mhm.
of speed things up. So things that we've already installed and maybe like the first stage, we don't have to reinstall in the second stage.
Exactly. Exactly. You could dump all of that out. And so you have the choice now as the developer how much of the artifacts created in the initial phase you want to carry over to the next phase. And the examples that we have right now aren't very complex. So, uh, if we look at this, for example, I guess this is the same one. Okay. Now, this isn't, I don't think it's the example I wanted. Not it either. Sorry, I'm like having trouble finding this. Okay, okay. I think this is it. So let's look at this first example line by line, and I'll move it over to the actual README. I'm sorry that I didn't do that. I thought I did, but I didn't apparently. We have a multi-stage build here, as we can tell from the multiple from statements, right? So we create a working directory, we copy over our requirements.txt into that container, so then we can run pip install, et cetera, et cetera. And then we copy any remaining files. From there, we go to the next stage and we repeat these steps, right? We create another working directory. And then we could directly copy everything from the app directory in the first build, the first stage, to this one. So does this make sense?
What's preventing us from just doing this in just one build? Why are we separating it? I still don't really understand why we're separated.
Right. That's that's exactly the point that I'm trying to make. This is not a good example, right? It doesn't make sense. This would have the exact same result as a single stage build. So this is an example of like a poor implementation of a multi-stage build, right? Because if we're just copying the application directory from one folder to another, you're not really utilizing the benefits of the multi-stage build, right? So if we change this example around, for example, what we could do is we could take the requirements and divide it into two separate files. Now we have a requirements.txt and a test requirements.txt, and these will have different packages necessary for the application, right? And so you'll run in your first stage the setup steps that will allow for the application to run and for the testing of this application. If you remember from last week when we walked through the Docker Compose file, we had three stages. In our second stage, I don't want to confuse things. It was workflows, right? So we had three different work jobs within a workflow. And the middle job was setting up a Python test environment. This is essentially the same thing. We don't need all of those test packages in production, right? So we could separate those out, and then in our next stage, we explicitly only mention the requirements that we do need for production, and we leave out the test requirements. So does that make more sense?
Yeah, it's gonna take a while for me to get it.
Sure. Okay. Um, might have maybe I don't know if I had confused the issue at all by like just going way too far into like the conceptual side of things, my bad. It really is pretty simple in the sense that the point is you can you can exclude packages from the final build. You can exclude packages that you'll need for other things like testing, setting up a test environment, linting, etc. And that's just one use case. Let's go over to Docker's website, and let's look at some use cases that they provide. Okay, so what do they say? Debugging a specific build stage, using a debug stage while debugging symbols or tools are enabled, blah, blah, blah. So, right. A lot of you have been saying it might make more sense once you go through it live. Yes, it will definitely make more sense once you go through it live. And we don't have very robust or complex examples to really demonstrate that. We have very foundational examples. Um, but let's actually move on to the next point, and maybe this will help too, right? So not only are we able to configure multiple stages, but we could also call and limit our calls to specific stages. So in this example here, when we run our build command, we pass in a target option with the name of the stage that we want as a parameter. So here in our configuration, we use as, the keyword as, in our from statement to name a stage. So this first stage is now called builder. And if we target builder specifically when doing a build, it will only build this, this part of the configuration when wherever this is happening, right? This could be happening inside of your GitHub Actions workflow environment. It could be happening on your local machine. It could be happening really in kind of any kind of space, depending on how your pipeline is set up, right? So again, these are simple examples because aside from, like a requirements.txt file, like what else are we really excluding, right? When you get to your place of employment in a real world scenario, that's where you'll really start to see more complicated and complex examples. Off the top of my head, we work with Ruby a lot. So when you're creating a Docker file for a Ruby application, you're going to be running commands like um, bundle install, bundle lock, things like that. And there is a lot more junk, unnecessary artifacts that you can exclude from your final optimized image. I would say the same goes for Java applications. And I think Chandra might have an example of a Java Spring Boot app that he'll go through with you guys on Saturday. So today, let's focus on the basics of a multi-stage build, just creating a multi-stage configuration in the first place and running it, and you'll be exposed to it more and more. If you all remember from even longer back, when I was running the pipeline during the GitHub Actions portion, I was seeing issues with the elk stack starting up inside of the EC2 because of memory and space issues. In a case like that, I could start to do things like using Alpine images, which are more lightweight than the original distributions. I could also utilize multi-stage builds in the Docker files to further lighten the load, right? So my point is basically, will you need to use multi-stage builds? Will you need to use Alpine images? It's all going to boil down to your use case. Let's see here. So let's run through creating one of these.
Can I ask one more question, Julius?
Sure.
I'm just really trying to hone in on this. So the first stage gets built.
Mm-hmm.
And if we don't explicitly say just to run the build, it'll automatically go to stage two. Now
Mm-hmm.
in stage two, when it creates that final image, does it delete some of the previous requirements that weren't needed? Or does it just You see, that's a part where I'm kind of confused.
Yeah, yeah, definitely. Okay. So in our pipeline, let's say we have our workflow set up so that it's going to run Docker Compose, and each part of the Docker Compose is going to be running a Docker file for each container. Inside of GitHub Actions workflow, we have the first part of our build where this is generally where you would be running tests, right? So you're not going to have the final running image just yet. GitHub Actions workflow is kind of like an ephemeral space anyway, right? Like it's going to spin up and then it's going to spin down and then everything's going to be gone. Everything that was in that session is going to be gone unless it's pushed, right? So this is what's going to be built and pushed. At the end of that build phase inside of in the middle of your pipeline, this image gets built. None of this stuff, none of the test requirements gets included, and this gets pushed to your registry, be it Docker Hub, GitHub Container Registry, or something else entirely like Artifactory. And now your image that's been pushed there, which is going to be used on the EC2 or the on-prem server, wherever it goes, it's not going to have these test requirements. Does that make sense?
Yes, I think I'm starting to get the picture here.
Okay, cool.
So like, yes. So when you do the Docker Compose and like the pipeline, you do Docker Compose originally, and then at some point you end up with this final image,
Hmm.
which is what we actually deploy to multiple instances.
Exactly.
Okay, I
Exactly.
got it.
Exactly. Yeah.
Oh, so you're saying if you didn't have the stage two, you'd have the requirements, text, and all the junk stuff that you don't need. So the stage
Exactly.
two just removes everything from the stage one.
Exactly. Exactly.
Oh, okay. Yeah, that makes perfect sense. Oh.
Right on. Awesome. Okay, cool. So that's the whole point of multi-stage builds. Let's see. I was about to like dig for another more complex example, but I don't think we need to do that now. Let's see. Let's run through one of these examples. I honestly don't really like these examples. I don't know where they came from. I think they look very ancient, but why not, right? I don't even understand why it wants us to manually create a package.json file. That's just so bonkers to me. Okay, let's see if we can just start from here. Okay, go up one directory. We're no longer in February. March directory. There's 3, 2025. And okay, we're gonna create a React project. So let's make a new directory. And let's run our installation command. So this first part, for those of you that haven't taken the full stack curriculum, is npx is a package manager, node package manager, and it's got an npx command that's going to allow us to build a React app, and it's going to set up our project with all of the necessary stuff. Once looks like a really old example. Like it even has a link to create React app. Let's let that do its thing. Actually, I might even just kill this and go with something a lot faster. Okay, well, it finished, whatever. All right, so now that this project has been initialized, if I do my npm run, just npm start, oof. Add it to load it here. We have our React application. Okay, so let's shut that down. Now what does it want us to do next? It's not even the right file. Yeah, lost it again. It's this one. Oh no, it was this one. Okay, so where were we? We've set up our project. Now we want to make a Docker file, and we're going to call it Docker file single. And we're just going to go ahead, add all this stuff. Again, from is what you use to name your stage. I'm sorry, I got distracted by this. I don't even know what Puppeteer is. I don't think I need this. We'll get rid of that. And I am going to save this. And let's see. So now I have my Docker file. Now I can do a Docker build. Let's tag it with a name, tstage, latest, and oh, right. Need Docker. Let's give that a moment to spin up. Okay. Well, that should be good. And I want to specify a specific file because it's not just called Docker file, it's called Docker file single. I'm going to use -f. Because that doesn't like -f. Or I still have to pass in the path for that file. Okay. So let's see. I'm gonna build and we can run this image. And then I guess there it is. There's the key thing here. So again, for those of you that that have not taken the full stack curriculum, let's talk through what's happening in this npm install. When you run npm install and npm run build, you'll see inside of your React directory, and maybe I should actually do this inside of the container. You'll see the compiled files, right? Because what's happening during the build is it's interpreting everything inside of the source directory and the React compiler is going to compile it into um, the necessary files for production. So like your index.html and all of that stuff, right? So let's go ahead and run our image, which is called, ooh, I got to run prune. A lot of crap on my machine. Which is called multi-stage. Run. Yeah, let's do an RM as well. I don't know why I did that. I'm going to map some ports, apparently. Okay. So what's happening now is we are, we've built our image from our single stage Docker file. Its final command is to run npm start. So npm start has been run inside of the container. Because we've mapped our ports, we can see local 3000 inside of the container through our own local host 3000 on our local machine. Okay, so that's good to go, right? I'm going to open up a separate terminal, and I am going to look for my current container, which was just randomly named Hungry Beaver, apparently. I'm not going to use the name, actually. I'm going to use the container ID. So I'm going to do docker exec contain. I'll use the name. Docker exec IT, Hungry Beaver. And let's just see if this works. Nope, doesn't like that. So let's try bin bash, or maybe even just shell. Okay, shell is fine. I'm now inside of my container. And if I do an LSA, we see that we've got our source directory, our public directory, package.json, node modules. What I'm trying to look for is the folder where you would find all of the compiled React files. In the dev environment, that just gets created at the root directory. Now, trying to think, where would I find it? Not app. It'll take me all day to find this. I'm not very fluent with search commands, very bad at searching. So let's see if we can find another example. What I'm really looking for here is just so y'all could see if, especially if you don't have a lot of experience with React, is here it is. Here's a good example. So here's another project, another React app. When you run your build, your npm run build or whatever, this is the compiled folder. It's inside of a distribution folder. It's grayed out because it doesn't actually get pushed to the repository, right? By default, if you set up your git ignore to use the node template, it will know to ignore the dist folder because we don't want a distribution to be pushed to the repo. Like this, we don't want the compiled files up there. What's the point of having the source files if you have the compiled files, right? So this is essentially what I'm trying to look for inside of our container. And basically, in the multi-stage build, if you look at this line in particular, from app build user share nginx, what's happening here is instead of copying everything from the original project, which means the source files, we're only copying the compiled build, right? So this makes it more lightweight. We don't have the source files in the final image. This is the image that gets sent to production. This is what's going to be run, and it has only what it needs to run the application and nothing else. I was hoping inside of app that we would have that build folder, but apparently not. So let's exit out of this and let's go ahead and make our Docker file multi.
Julius,
Yes,
can I ask a question?
sure.
The line on stage two that says copy dash dash from equal build slash app slash build,
Hmm.
uh, is this your working directory in this? Like, is this your directory where your files are and then you're copying it to user share nginx HTML inside the container?
That's what I thought, yeah. But when I went into the container, I didn't see that build direct,
Yeah. It's
right?
weird.
Yeah, it is weird. I didn't write this example. This is actually a very old example. I think Adam might have wrote this. I think this was from the original version of the cohort.
Oh boy.
I haven't tested it myself yet, basically, is my point. We're going through this for the first time. Um, I'm gonna try to run it now from the multi and see what I see inside of the container. But a few things to point out. Yes, the from build is referencing the stage as we named it up here. And I'm hoping that once we run this, oh yes, there we go. There we go. There's the difference there. See how in this single run Docker file, we're only running npm install and npm start. We're not actually, we haven't built. We basically haven't built the app.
Okay.
Okay, so that is what solves the mystery. It wasn't even inside of the original Docker file. Okay, so I think it would have made sense to have that in the original Docker file just for demonstration purposes. But now if we run this Docker file multi, we should be able to see this build directory inside of the container. And I wouldn't have to dig for all these other examples. Okay, so we're copying all of the necessary things. The package.json is like the equivalent of requirements.txt. Once we copy that over, we also want to copy over all of our files, which will include the source directory. Why we don't just do the copy by itself, I don't have a great answer. Maybe it's just good practice to be explicit about copying over the files that contain essentially the instructions for how to build your app, right? So that's just something you'll see a lot. Now we're going to run these commands. And again, the difference between run and CMD is you could have as many run statements as you want inside of your Docker file because run is what's run during the build. CMD is what's run at the end of the build. Okay, so here's our first stage. Now stage 2 from engine X. I'm going to name this final. That's interesting. I just noticed as well, we're using a different base image, right? We don't need all of the bells and whistles that comes inside of the node image because we don't need all of those files, the package manager and all of the stuff that will help us build the application anymore. Now we could go with an even smaller base image, Nginx, which only has the necessary files for serving our pre-compiled application, right? So this is a much better example than the simple Flask example from earlier because now we're seeing um, additional ways the multi-stage build is helping us create a leaner final image. So we are going to copy from our first stage, from our working directory to the directory Nginx is going to be serving the files from. And we're going to expose port 80, which is the default port for HTTP connections. And it's the port that Nginx is going to be listening for. And then we're going to run this Nginx command at the end of this build. So now let's go ahead and build this Docker build. We're going to tag it. We're going to call it React Multi. We're going to specify the exact file that we want because we have multiple Docker files. And we're going to pass in the path where it's going to find this file. Should create an image. And once we run this image, we'll exec into it and we'll go look for that build folder. Actually, now that I think about it, we shouldn't find that build folder in there. Can anyone tell me why we shouldn't find the build folder?
Does it depend on the work directory you used? Where you copied it?
It's more about the stages. Actually, I'm wrong too. Like, what am I saying? We should find the build. Well, yes and no. We wouldn't find the build folder in this path because it's getting copied over to this path, right? But also, we're running the entire multi-stage build, right? So all of this stuff is going to get thrown out the window. Now, if I run my build command to specifically target this first stage, so let's do a target. What's the name of this build? And we're going to name it something else. Multi-stage 1. Here in this image,
NPM is missing.
yes, it is. Wait, why is it missing? Oh, because of course, because I'm a derp. Thank you. Okay, so now I'm going to save. I think I'll probably have to rebuild that first image too. So okay. So now I'm going to rebuild the first stage. In stage one, we should be able to find the build folder because running the build will create it. And in the full image, full doesn't really feel like the best word to use. In the container that we create from the entire multi-stage build, we also shouldn't see the build directory, at least at this path, but we should be able to see this path with all of the build files that we need. So let's go ahead and exec into this. Once it's finished taking its sweet time.
Is there any reason you would want to specifically tell it which stage to run instead of just running the full file?
Oh yeah, definitely. So let's say for our current use case, right? Like we're separating out like the compiling of like the image versus um pushing the final outcome to like some kind of a staging repository like Docker Hub or GitHub Container Registry. We would probably have different pipelines that utilize different build commands, right? Like we could have a pipeline that utilizes the entire multi-stage build for when we want to deploy the application. We could also have a separate pipeline for, I'm trying to think of like just examples off the top of my head. In this case, this could be like a precursor to some like alternative things, right? Like we could run this, push this to like a staging registry or a development registry, and then run tests from there. What else? I'm trying to think of like actual use cases for something for like this example is is, is tough. Let me talk about a use case at Innova at work. So we have we have a simple two-stage build for a lot of like our user-facing applications. So, you know, like I work at a fintech company, so there's going to be like cash or loan apps, basically. You sign up, you see if you qualify, et cetera, et cetera. Now, as developers are working on these applications and adding and testing new features, they have multiple ways they could go ahead and do that. They could work locally, which probably is limiting because they won't have access to a lot of APIs. Um, but once they're done with that local development stage, they can push to another development environment that runs. We have a very specific Kubernetes based development environment that allows developers to spin up as many instances of their application as they want, right? And so the first part of their multi-stage build will trigger that, and then it will just run through a different path. It's going to send that image to a different registry than what you would see in staging and deployment. So now they have like this playground where they can continue to test these features, but in a more robust environment with access to like databases, production, well, maybe not production database, but like databases and APIs. And once they're satisfied with that, then they can go through the more rigorous process of pushing to staging. So now that they push to the staging environment, they want to make sure these new features are going to be running through tests all these tests pass, and that it their new features play nicely with every other part of the application, right? And the whole and what's the difference between a development environment and staging environment? Development is more like a playground, right? And staging is staging for the actual final deployment. So we need staging to mirror production as closely as possible. And this will let us know if it fails in staging, it's very likely going to fail in production. So we could have this first part of the stage, or the Docker file, this stage basically run the build to different destinations. One can go to development registry, one can go to staging registry, and one can go to a production registry. Does that answer your question?
Yes, very much so. Thank you.
Sure. Okay. So, all right. This has finished building, which means now that if we run this, I'm just trying to look for the command I run earlier, and it's gone. Oh, actually, oh, did I just use Docker exec? Let's see. Oh, my run command went. Okay, so now I have this React multi-stage one. And then I have my old multi-stage. I still have to rebuild the multi-stage because that one was probably bad as well. So let's also rebuild the original multi. I forgot my version number. And let's see. While that's happening, let's open up another folder for terminal. And oh wait, it finished. Did it finish? Okay, that was pretty fast. Okay, so now if we run one of these, okay, multi is the one that used the entire Docker file, and stage one was limited to stage one. Let's go to stage one first. So let's do Docker run. Oh, and let's also look at this. Let's look at the image size. Notice how our stage one build is 761 megs and our production build is way smaller, 198 megabytes. That is the power of multi-stage builds. Okay, so a Docker run, multi-stage one. Let's see. I wanted to also run RM. What else did it want me to do? Oh, right. I have to map ports. So let's do 3000. Actually, I think I have to do 80. Yeah, 3080. Because now we're using Nginx. And shoot, I still have this running, right? Okay, so I use 3001. Okay, now that should be running. And I should also, oh, I think it might have stopped. Or did it not run at all? Nope. I'm seeing it. Okay, let's also try to run the other one. So let's do just the React multi. Okay, so that one's running. Oh, okay. So this, what I'm thinking is this first build, the Docker multi-stage one, isn't running because there is no command at the end. Okay. But we have the full container running. So let's do PS. Let's also see if this is actually up. So let's do localhost 3001. Cool. It's up, it's running. And let's go into our container, which is called Practical Driscoll. And I want to, let's just use shell. Okay, so ls. Now we should be able to go to user. Notice how there's no app directory in here. Should be able to go to user, share nginx, HTML, and we see our React files. Let's take a look at our index.html. Oh, shoot. Vim is not on here, so let's just use cat. Okay, cool. We see some proof that this is our React app. So we have in the metadata, content equals website created using create React app. Oh, here's the title, create React app, and logo. Okay, so this is the file that Nginx is serving right now. And if we exit out of this, I wonder if I can. I mean, it's kind of absolutely unnecessary now, but I still want to get into this stage one image just to see if there's a build folder in there. Um, so let's see. I don't know if it's gonna work. It's gonna complain that the image or the container isn't running. So why? I pass in a command while I'm not sure. I've never done this before. I've never tried to run a Docker image, or sorry, Docker image built from a Docker file without a command at the end. Never had a use case for this. I'm gonna see if, oh, did it go? Or did I? Yeah, that's the wrong one. I don't want that. I need to run this, or I want to try to run this. I don't need to run this. Okay, yeah, this is silly. I guess I'm going to continue to try to keep forcing this unnecessary thing to happen. But what we did see is once we built both containers, or we ran the containers from the images, we saw that one was significantly smaller than the other one, 198 megabytes versus like on the Docker PS again, versus like 700 or something. Or not Docker PS, Docker images. Right. So in our multi-stage build for this React application, we did two things to lighten the load. We, in our second stage, used a lighter base image, and then we also excluded all of the source files from the final build. Okay, so that is multi-stage build in a nutshell. Any questions? Okay. Oh, I shouldn't have stopped sharing. Let me share again just so we could talk through the challenge. Okay. You all should have. Well, actually, I'm curious. I don't know if anyone is actually doing this. Has anybody been working on like a continuous pipeline, or have you all just kind of been starting a new project for each challenge, for each individual challenge?
New stuff.
New stuff. Okay.
Same, new.
Okay. Okay. So I was gonna say, if you had been like working off of like the same pipeline, one thing you could try is to take your existing Docker file and see if you could optimize it by converting it into a multi-stage build. You can also do that with any of your past projects. Otherwise, there is today's challenge where you basically will create a front end for a to-do list Flask app, and you will create a multi-stage Docker file for it. So pretty much what we just saw in the demo, um, using this repository. And then a little more complex version of that is working with an external repository, React Clicky Game, which I don't think is actually up anymore. So that is today's challenge. I'll be here if anyone has questions, and let's think back up at 9. Sound good?
Yep.
Sure.